All right, so the next section, you guys see this right here? Okay, 1.3 is called trigonometric functions. Okay, we did this at the very end of last year. They throw everything that we did like all into one section. Okay, so you could spend like months learning trig. So we gotta kind of relearn the basics, make sure that we have enough to proceed through doing calculus, yeah? For one, okay. Just look up here for right now, and then I'll come and check it out here in a little bit. Okay. So, you guys remember trig? Okay, do you remember what a radian is?
If you're following it says this page, I think it's sinking.
Okay, try, okay. So do this. Push here, hold it, and then go seek. Where am I holding? Up on the notebook. Right click in or middle finger. Right click in.
No, that's true.
Sync this now. Yep.
Well.
And if it's not syncing, we'll figure it out later. I'm not sure what's going on. It might take a second. All right, so a radian. So basically, a radian is a unit of measurement. Okay, so if I ask you to show me what a 60-degree angle looks like, you could do that, right? Okay, you kind of go, right? Okay, well, a radian does the same thing. It's just a different kind of measurement. Okay, so we use different units. Okay, so a radian is directly related to circumference. Okay, so does anybody remember what the circumference of a circle is? 2 times pi times the radius. Okay, so let's say we let our radius equal 1. What would be the circumference of that circle? 2 pi. Okay, so we use that idea to do our conversions. Okay, so we can say that if I go all the way around a circle, how many degrees would be all the way around a circle? 360. So we can say 360 degrees is equivalent to a complete circumference of 2 pi. Okay, so let's go half that. Let's say I was going to go half of 360 degrees. What angle am I talking about? Okay, so degree-wise, I'm saying that's 180 degrees. How many radians is that? 1 pi. Good. Okay, so you remember this a little bit, yeah? Okay. Kind of, sort of. So, do you remember how to convert from let's go degrees first, degree to a radian? What was that? And what do you do with 180 over pi? Multiply. You're really, really, really close. Switch it though. There you go. So the way that I always remember that is that a radian always has a pi in it. Right? You always see them with pi's. So for me to get a pi in there, I want to multiply by a pi. Okay? So let's do a quick example. Give me an angle.
90.
Okay, a hard one.
90, 27.
Ooh. Okay, 27. Sorry, I heard that one first. Okay, how would I take 27 degrees and convert it into a radian? What would I do? Bless you. You would multiply by pi over 180. Okay, so the way you want to kind of think of this is I have 27 over 180 and then being multiplied by pi. So we can kind of think of this fraction as something that I'd want to reduce. So how can you reduce 27 over 180?
3.
Okay, you can divide by 3. What? Divide by 9. So what's 27 divided by 9? So we'd have 3 pi. What's 180 divided by 9? 20. Okay. So 3 pi over 20 is equivalent to 27 degrees. Do I need to do another example of that? Is that pretty easy? It's pretty straightforward. Okay, let's go the other way. How do you convert from radians to degrees? Yeah, so same idea, but we're going to multiply by 180 over pi. So we need a radian angle. Hit me with a hard one. A radian angle. Radian angle. I need a pi in there somewhere.
Pi over 46.
Ooh, icky. Pi over 46. That was nasty. Okay. Pi over 46. So what is pi over 46 as a degree angle? Okay, we're going to multiply by 180 over pi. So we have like two fractions that are being multiplied together. How do we work with that? Cross them, like pi's cancel out. So now we're reducing 180 over 46. What do you think we can divide that by?
2.
2? Okay, what's 180 divided by 2? 90. What's 46 divided by 2? 23. 23 is prime, so that looks good. Ew. Now you could leave it like that if you feel like you're like, oh man, we're talking about a degree, I want a decimal. You could divide that and give me the decimal. Anybody know what 90 divided by 23 is?
Top of my head.
3.913. Thanks, Alexa. That was nasty. Okay. Now make sure you label it. You should have a little degree symbol, even on that fraction that was icky. You usually don't see degrees written as fractions, so make sure you have a degree symbol. All right, clear on that? Pretty easy. Okay. Let's talk about drawing radian angles. Draw. Let's see. Let's not do too icky of one. Let's see. 7 pi over 4. Can you draw a radian angle? Do you remember how to do it? Okay, yeah, you think of it like a unit circle. Okay, so you take your little circle and you draw a coordinate grid through it. Okay, and what side do I always start with? Top left. The right middle one. Yeah, this one right here. Okay, so this is always going to be your starting spot. So they call that the initial side, which makes sense, right? Initial, where we start. Okay, now what? Nice. Okay, so the way that you want to be thinking about this is that half of the circle is pi, right? Okay, it's like 1 pi. It's like our one whole. Okay, so how many sections am I going to cut my pi into? Did you say 4 or? Yeah. 4. The answer is 4. Yeah. So we're going to cut this into 4s. So we're going to take this top half, cut it into 4s. Okay, so if I cut that into 4s, here's half of it. Okay, there's 2 more, so that's 4. Okay, so then I just start counting it out. Okay, and this one would be 1/4, 2/4, 3/4, 4/4, which by the way, 4/4 is the same as 1, so 1 pi. Now when I ran out of pies or sections, what do I need to do? Cut the bottom. I need to cut the bottom half so I can keep counting. Okay, so I have 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4. Okay, so that spot right here is 7 pi over 4. Now, can I just leave it like that? Is that it? Okay, I gotta show that little line. Like, how did you get there? Okay, that little like revolution line. Okay, so this right here, by the way, is called. Do you know what that line is? The one that's at my 7 pi over 4. What that is called. So if this one's called the initial side, this one's called the. This is the start. This is the place for our destination. Think of an airplane. At the airport.
Terminal!
Terminal, there it is. Terminal side. Terminal in reference to your place of destination. Okay? So you gotta have this little arrow showing us how you got there. Because otherwise, maybe someone could have come in like this direction and gone downwards. Right? So if I would have instead, let me draw it over here, gone like this, what angle is that? Negative, right? So if I go in it downwards, that's a negative direction, so that's negative pi over 4. Can anybody tell me what negative pi over 4 and 7 pi over 4 have in common? Huh? Nice. They both like have the same ending spot, right? They both have the same terminal side. Okay? And that's called a coterminal angle. Okay? So you need to know how to find coterminal angles. First of all, what's a coterminal angle? Explain it to me. Okay, angles that have the same terminal side. Okay, but maybe we took a whole different revolution to get there. Okay, so how could I go from 7 pi over 4 and get to negative pi over 4? How can I find coterminal angles? You add what? 2 pi, 1 full revolution. Okay, so to find coterminal angles, we simply add or subtract 360 degrees or 2 pi, depending on what we're working in. Are we working in degrees or radians? Shall I do an example? Okay, how about 230? Give me a positive coterminal angle. What do I do? You add 360. Good, there you go. Okay, so if I was asked for a positive one, I would add. What if I was asked for a negative coterminal angle? I would subtract. So what's 230 minus 360? Negative 130. Nice. Do I need to do an example in radians? That's harder. Let's do a radian. Okay, give me an angle.
4 pi.
4 pi over, give me something slightly harder. 4 pi over 5. Okay, let's find a coterminal angle. So what would I do? Add 2 pi. Okay, now when I'm working with fractions, what do I have to have? Common denominator. So this is technically over 1. What's my common denominator? 5. So 4 pi over 5 plus what?
10 pi.
10 pi over 5. Good. Now I add my tops. And 4 plus 10 is 14 pi over 5. Shall I do the negative version, or are we good from there?
Okay.
Got it? Okay. Second half of this is finding exact values of our 6 trig functions. So, do you remember your 6 trig functions? Okay, so we have sine. We have cosine. We have tangent. And then we have the ones that are the reciprocals, right? So what's the reciprocal of your sine? Cosecant. What's the reciprocal of cosine? Secant. And tangent? Cotangent. Okay. Now, I don't know how far back I need to go here. Okay? The first time you learned trig with sine and cosine and tangent, it was in reference to a right triangle. Do you remember this? Where we had, let's say here's our angle, we had the hypotenuse, we had the opposite side, we had the adjacent. You remember this? And then you learn that fancy little phrase that goes, so, ka. So, you remember that? Okay. So basically that told us that the sine is equal to opposite over the hypotenuse. Do I need to write this down?
No.
Or is this old school news to you? Old school news? Okay. So now we take this in a little bit further and take this whole idea and put it onto a unit circle, right? So let's say this is here. Okay, and now since we're working on a coordinate grid and this is my angle, if I go to the right, what kind of value am I talking about? This is the x value, and this is the y value, right? And what's my r on a unit circle? It's a 1, right? Because it's d units, 1 unit of circlage. Okay, so if we take now this x and y idea and try to remember what our sine and cosine and tangent are. Can you remember? Do you remember what the sine is? So remember that the sine is opposite over hypotenuse. So in terms of my unit circle, what is it equal to? Y. Straight up y. Okay. What about cosine? X. Tangent? Y over x. Good. Okay, and then our reciprocal functions just literally come from the reciprocals of the previous. So what is cosecant equal to? 1 over y. So you just flip your y. What about secant? 1 over x. And cotangent? Very good. Alright, so at this point, we need a unit circle. Now, do you want me to go through how you set up a unit circle again? Because that takes like a good solid 20 minutes. Or should we like hit up Google and pull one off? Okay, now what if I ask you to memorize this and give you a test on it?
We had to last year.
We had to last year, and it's an important piece, so you need to still be able to do this. Okay, you guys have laptops, you could do this too. I'll put this one in, and I might even go as far as printing one out for you. Depends on how nice I feel, how much time I have later today. Alright, let's find a good one. Ooh, that one looks good. How do you guys feel about this one?
Very nice.
Is it fuzzy, or can you read that well? I feel like it's not super nice. I feel like we can do better than that. Let's see, I like this one. Oh, that's good. I like that one. That one is nice and clear. Woo! There we go. How's that look? Nice. Everybody got a unit circle in front of them? Guess you could look up. That's kind of hard to see. All right, here we go. Let's do a couple of examples of finding the exact value. So just a hint for you, when you see the words that say find the exact value, and you see trig stuff out after it. Sorry, my handwriting is not very good. That means that's just code for use your unit circle. Got it? Okay. Can you tell me what, let's start easy, the sine of 2 pi over 3 is? Okay. Does everybody find it? Okay, so on your unit circle, you go to the angle, 2 pi over 3. Oop, there it is. And what are we looking for? The y of the ordered pair. So I look at my ordered pair. The y value is the square root of 3 over 2. That was easy. Too easy? You're supposed to say yes. Tangent of 3 pi over 2. What is the tangent of 3 pi over 2? Tangent of 3 pi over 2. Did you find 3 pi over 2? 3 pi over 2. Okay, what is tangent? Y over the x. Y over x. Negative 1 over 0. What's negative 1 over 0? Oh, buddy. Can you divide by 0? Oh, that was a bad 0. So what is this one? Undefined, okay? Do I need to do an example of one of the reciprocals?
No, thanks.
Yes? Going 1, yes?
Yeah, actually, yeah.
Good call. Okay, third one, let's do the cosine of 3 pi over 4. Cosine 3 pi over 4. Okay, so find 3 pi over 4. Okay, so how do you find, did I do cosine?
Yeah.
Oh, my bad. So I meant to do secant. Just kidding. My bad. Secant. Change that to secant. I meant to do a reciprocal. Secant of 3 pi over 4. So 3 pi over 4. What is the cosecant of? Or what did I do? The secant. My bad. Jeez. Secant. Secant is what? 1 over x. Okay, so my x value is negative square root of 2 over 2. So if I'm going to do the reciprocal, what do? Just flip it. All I have to do is just flip it. So it's going to be negative 2 over the square root of 2. Can I leave it like that? No, we got to bring the square root up. Okay, this becomes negative 2 square root of 2 over 2. The 2's cancel, and we get? Yeah. Okay, your turn to see if you actually get this. Prove it. Everybody go to Nearpod. Okay, so open up a browser. I prefer Chrome. We've had some issues using Edge, so I don't think you should use it. It's been freezing. Password is subkeg. Okay, did everybody grab a stylus? Make sure you have a stylus. By the way, those styluses are super expensive, so please make sure to get back into this box by the end of the class today. If I lose them, you're going to have to start back. So, in the code, oh, thank you. Everybody has a name? Yeah, you turn in. All right. Okay. All right, so your first question, let's see, let's go down here. Bloop. Nearpod. Ooh, let's stop the recording.